Hi. After watching this presentation, you should be able to explain the difference in the fault detection setup for short faults when we go from single to multiple boundary scan chains, and also how these faults can be detected. So let's start with the difference between these two cases. Of course, the shorted pins behave in the same way, but we can only be sure of having set up opposite logic values after driving all the outputs in all the boundary scan chains. So the simple rule that we have to follow is that we cannot start capturing the test responses before having shifted the test vector bit streams into all boundary scan chains and gone through the update data register state. Then we can go through the capture data register state in each boundary scan chain, one after the other, until all test responses are captured. And please notice that the same applies to open faults. It's just that the fault detection conditions will be different. So let's consider the case of short circuit X9. X9 is driven by the outputs that belong to the light brown boundary scan chain, and the test responses are captured at the input pins that belong to the light blue boundary scan chain. So in this case it is simple. We only need to shift the test vector into one of the boundary scan chains and to capture and shift out the responses in the other boundary scan chain. As a simple exercise, I would like to ask what specific test pattern would you choose to drive the outputs, since we are now considering a short circuit involving 3 pins. Would it be the same to choose 101 or 010? And would it be different if another fault was present at the same time, for example, X4 or X5? Notice that a short circuit may override a 1, bringing it to 0, but then this error may be masked if that same pin connects for a word through an open fault that causes the associated input to capture a 1. Thanks for your attention. This is all.